All right, so the next part of section 2.4 that we're going to look at is dealing with slope. And I tell each of my classes every semester when we talk about slope that of all the things we talk about, this is probably one of my favorite topics because it is very applicable to the real world. And so we're going to talk just very briefly about a few things from a real world standpoint before we jump into the um, the algebraic side of this. Okay, so one of the things that we need to understand is that every line that we look at, every one we've graphed so far, every one we're going to graph, all have a steepness. And this steepness can be measured. We call this steepness slope. And so you kind of know what a slope is. For example, if you were to look at a hill, or you were to look at a mountainside, or you were to look at your rooftop, or a number of other things, you could say, oh, well, that has a slope. We kind of know what that looks like. And if we were in class, I would give you a ton of examples kind of relating this to you. I'll use a couple here in the video, but slope you can see all over. We see slope all the time. But what I really need you to understand is that slope is simply a ratio. It is simply a way to compare two things. Now, from a line standpoint, the two things that we are looking at, we're comparing, are vertical change up and down compared to horizontal change right and left. And so when we talk about the steepness of a line, we describe it by comparing how much it changes vertically compared to how much it changes horizontally. And so we call that a vertical change divided by a horizontal change. You could also use this notation, by the way, that the delta symbol means the change in y divided by the change in x. That's how we would say that. You've also seen this probably referred to as rise over run. The rise being our up and down, the run being our right and left. And so we can look at a line and talk about, well, how much does it rise going up and down? How much does it run running right and left? And so we use this lowercase m as the symbol for slope. And our slope formula, you need to make sure that you've got in your notes somewhere, is this formula, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, when we look at the slope, I was teaching a class one time at night, and I had a guy that did construction during the day. And we got to talking about slope, and I had not made all the real world connections. And he just, in the middle of the class, goes, I use this every single day. And I said, oh, really? I said, tell me about it. He said, well, I do construction. And he said, when we build a house, we have to use pitch. Well, if you don't know, pitch and slope are the same thing. And so he talks about how they use pitch in putting a roof on a house. And I was like, oh, yeah, that's really cool. And we kind of related that to what we were doing. About 5 years ago, my wife and I built a house. And my builder came to me and he asked me about the pitch of my roof. And he said, what do you want the pitch of your roof to be? And I said, well, what are my options? And he said, well, here's what your house plans say. And he said, we can do that. He said, or you can have a bigger pitch. He said, it's going to make your house look bigger, but it's going to cost you a little more money and material. He said, or we can make the pitch smaller. It's going to make your house look smaller, but it is going to save you some money. And so we talked about it, and we were able to figure out what we wanted to do. Well, just as a quick illustration, if this represents my house, when my builder came to me and talked about pitch, as we had that conversation, I had to assume that he knew what slope was, and he knew about slope. Because if he had built my house and he put a roof on it like that, well, then all of a sudden I got a problem, right? Because that's not covering my house. And so when he asked me about the pitch, what he really wanted to know was, how high do you want your roof to go? vertically, and then he was going to measure to see how far it needed to go horizontally so that then he could put the roof on and have the right slope or right pitch. And so then he could do the same thing on the other side and you would have the roof. And so when he gave me my options, when he said you could have a higher pitch, what he really meant is you could bring this vertical distance up and you could have a pitch like that. Or you could bring it lower and you could have a pitch like that. And you can imagine if you live in a large house or you've seen a large house, a lot of times those large homes have a really high pitch because it makes them look really big. And so when you see that, a lot of times the house itself may not be that big, but the pitch of the roof, the height of the roof makes it look really, really big. And so when we talk about pitch in construction, that's the same thing. And we could go into talking about wheelchair ramps and the slope of those. I give you one other example before I move on. When I taught at the high school level years ago, I always did an activity where I would take my students to the football field. And I would have them in groups of 3 or 4. And I would always have one person in that group sprint 40 yards, one person jog 40 yards, and one person walk 40 yards. And we would take their times and we'd come back to the classroom and we would graph each of their distances or measurements. And so what we would do is we would take the person that would run and we would look at their graph, and the person that would jog, and then the person that would walk. And so when we did this, we're comparing distance and time. Okay, again, it's a ratio. It's a way to compare two things. So we're comparing distance and time. Well, in this case, our distance for each of these was 40 yards. And then our time was done in seconds. And so as we did this, it never fails. The person that was one of the more athletic people in the class that was really fast or whatever, they wanted to be the one to run to show how fast they were. And so I had a guy one time run a 4.540. It's 4.5 seconds to run 40 yards. Okay, and so his graph kind of looked like that. Again, this is a sketch. It's not perfect. And then the person that would jog, theirs would oftentimes kind of look like this, where they still traveled the 40 yards, but it took them 8, 10 seconds, something like that. And then you would have the person that would walk. And I had a person one time that had a graph that kind of looked like this. It took them over a minute to walk 40 yards. They never stopped, but they took every step very slowly, and it was kind of painful to watch. But it did give us some really good data. So we were able to come back to the classroom, and when we look at these graphs, we can see what happens to the slope or the steepness when the speed increases or when it decreases. So when the speed increases, like in this first example, we have a steeper line, right? It goes up faster. As the speed decreases, like in this last one, then the line begins to flatten out some. And so what happens is, as we talk about speed, distance compared to time, we can visually represent that. For example, when we talk about how fast you went going to school or coming home or whatever the situation may be, you talk about your speed in what unit? Miles per hour, right? The miles tells you distance. Per hour is your time. And so we can talk about speed in feet per second or meters per second or kilometers per hour, yards per second. You can do a lot of different ways to talk about speed, but it's always distance compared to time. And so looking at this from the standpoint of a visual really helps us hopefully understand what we're talking about with slope. So one other thing that comes to mind, if you were to get a speeding ticket, and I always ask just because it breaks the monotony a little bit of the class, I always ask who's had a speeding ticket. and sometimes everybody raises their hand, sometimes only a couple people do. And so I use this example. If you took the speed limit of a road, whatever it may be, whether that's 70 miles an hour or 45 miles an hour or whatever, if the speed limit is represented by that line, and your line looks like this, you need to slow down because you're going to kill somebody. Because what you've done here is you have traveled a very, very long distance in a very short amount of time. And so the speed limit says, well, you should travel a moderate distance in a moderate amount of time. You've done the opposite of that. You've traveled a very long distance in a very short amount of time. You're going way too fast. Okay? And I say that in humor a little bit, but again, it hopefully gives you an idea about this visual that we can get when we talk about speed. Again, slope being very useful. And so what we're really going to focus on is finding the slope in different ways. So one of the ways that we're going to find slope is through simply the slope formula. On the previous slide, I gave it to you. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This formula allows us to take a set of ordered pairs and be able to find the slope, because we're finding the change in our y value, that's our up and down value, compared to the change in our x value, the horizontal value. And so in this case, if we were to take that formula and use it here, you need to understand both ordered pairs are an x and a y. So this is an x and a y, and this is an x and a y. The 1s and 2s mean first point, second point. So this first order pair are your 1s, the second order pair are your 2s. And so if we substitute all that into our formula, then our y sub 2 is 4 minus negative 1. So notice what I did there. I said 4 minus, and then went to see what that other number was. A lot of times people will say 4 minus 1 because you've got a negative 1 here, but it's minus negative 1 because that does change our value. And then on the bottom, it's the same thing. It's the x sub 2, which is 3, minus 4, because that's our x sub 1. And then we're just going to simplify that. So that minus a negative does make the 1 positive. 4 plus 1 is 5. And then 3 minus 4 is negative 1. And when we simplify, we find out there's a slope of negative 5. Now, one thing I think that's really useful and can be really, really helpful to you moving forward is to be able to get a mental picture of what it means to have a slope of negative 5. So when I tell you a line's got a slope of negative 5, I would love for you to be able to, in your mind, picture that line from a steepness standpoint. So in this case, what I'm going to do is I'm going to make a sketch for each of these to help you kind of get that mental picture. And so if I tell you that a line has a slope of negative 5, well, what it means is that if you have a point that's on this line, for every 5 units that you go down, 1, 2, 3, 4, 5, you can go right 1 unit, and you should still be on this line. Now, negative 5 is negative 5 over 1, right? Our rise, our up and down value is negative 5, so we're going down 5. The run being the 1, we're going to go right 1. And so when you do that, you'll see that you have this kind of line, that type of steepness. If you can identify what it looks like from the steepness standpoint, then later when we graph with the slope, it's just a matter of where does this go on my coordinate plane. Okay? This is the one time when fractions really are helpful when we talk about slope, because it does give us rise and run. And I do have some students that ask a lot of times, well, can I go left? And my answer to that is yes, but we're not going to. We're always going to go up or down first. If it's positive, we're going to go up. If it's negative, we're going to go down. And then we're always going to go to the right. That way we don't have to worry about a sign issue that could come up if you try to go left and down both. And so that can be sort of confusing. So we're just going to go up or down and always right. Now, I'd encourage you to pause the video, find the slope of the next two. If you are going to pause it, I'll give you 3 seconds. All right, so hopefully you stopped the video and you found the slope of each of these. Again, using our formula, it's going to be negative 9 minus 7 over negative 5 minus 3. And when you simplify that, it's negative 16 over negative 8, which then simplifies to 2. Now, again, from a rise and run standpoint, it's 2 over 1. We write it as 2, but it is still 2 over 1. And so, again, this mental picture, what does it mean if we have a slope of 2? Well, it means that if we have a point on this line, for every 2 units that we go up, we'll go right 1 unit, and we should still have a point on that line. So you can see that the graph looks something like that. And then the last one, kind of the same deal, we're going to use our slope formula. So it's 9 minus 4 over 7 minus 2. And 9 minus 4 is 5, and 7 minus 2 is also 5, and so 5 over 5 is 1. And so again, as we look at this middle picture, what does it mean? Well, it means that if you have a point that's on this line, if you go up 1 and right 1, you should still be on that line. And so our steepness then looks sort of like that. And so these are all sketches. They're not going to be perfect, but hopefully it does begin to build in your mind a visual of what these lines could look like. And so a couple of questions for you to think about. Number one, which one is steeper? As you look at that, hopefully you say, oh, the first one. The first one is steeper. It's got a greater steepness. And that's true. It does. And that should be fairly easy to see. It should make a lot of sense to you because the vertical change, how much it's changing up and down, is greater than the other two before it ever changes to the right, before it ever moves to the right. So you're changing vertically 5 units and then moving over 1, versus in the others, you're only moving 2 units or 1 unit before moving over 1. And so I hope it makes sense that that has to be steeper. Now, the positive and negative do not impact the steepness. The positive and negative tell us, does it go up or does it go down? As you look at these lines from left to right, if it is a negative, then the line has to go down. So if you see a line and it's going down from left to right, it has a negative slope every time. You can see that in the first example. The other 2 examples have a positive slope. And so if they have a positive slope, if a line has positive slope, they have to go up as you look at it from left to right. And you'll see that does happen with both of these sketches. Again,